Hey guys, hope we're doing okay at home. It's really weird not seeing you every day. Um, I tried this earlier today and the app crashed and deleted everything that I did. So there's already some notes on here that I took, but we're just gonna have to roll with it. But today we're gonna do 10.4. We're gonna talk about right triangle similarity and something called the geometric mean. And we've been talking about similarity already. So remember, shapes are similar if they have the same shape, but maybe are just different sizes. So one might be smaller or bigger than the other, but their shape's going to be the same. So we use proportions to help us find missing parts to those triangles. So we're going to look today just at doing right triangles though. So last unit, in unit 8, we were talking about altitudes, and I told you we would see them a little bit more later on. Well, today's the day we're going to use them. So we'll talk about altitudes a little bit and how we are going to use them in right triangles to find similarity, and then how we can use something called the geometric mean to find missing measurements. So again, today's only going to be using right triangles. We call them a right triangle because they have that right angle in the corner, the 90-degree angle. But let's get going. So, like I said, I did this earlier and it got deleted and didn't work. So I'm having to do it again. So there's some notes on here already. But for right triangles, if we draw the altitude, and if you remember the altitude from last unit, we learned will come from the corner of the triangle and come straight down so that it makes a right angle with the opposite side of the triangle. And I talked to you guys last time, or last unit, about how if you turned it so that it looks like a mountain, the altitude would be like the height of the mountain. So coming from the top straight down to the bottom. So you can kind of think about it that way as well. But when you draw an altitude in a right triangle like this, it ends up actually making two right triangles on the inside. We have this smaller right triangle and then this bigger right triangle right here. If you take each of these triangles and break them up so that you have the original triangle, but then you take this bigger piece and you turn it right here, and then this one I drew an orange. If I take this one and I spin it so that they're all facing the same direction, you can see that they create similar triangles. So we can use our proportions that we've been learning. And remember, a proportion is where you have a fraction equal to a fraction. And we can use that to find missing parts in triangles. So that's what we're going to be focusing on today. So I drew this one with purple on it, and then the smaller one using the orange pen to kind of help us label the two triangles here. Because sometimes the tricky part is trying to spin them so that you can get the correct parts matching up together. So if I take the bigger part, the bigger right triangle from the inside, and I spin it, the short side of this triangle is lining up with this altitude right here, which I called X. So I'll put an X right here. And then the longer leg matches up with this piece right here from the triangle, and I called that one Y. So we'll just bring that Y right here. And then this would be the hypotenuse, the long side. So I just put an H there. And then if I do the same thing for the little orange triangle, we're going to take it, spin it, think of flipping it. The short side of this triangle that I called X goes right here, where the longer leg is now coming from the altitude. So that's going to go here. And then your hypotenuse is from this piece of the big triangle. So if we have them lined up, we can now write our proportion. So remember, writing those proportions, the order matters of how you write the different parts. So if I take this leg on the purple triangle, I need it to match up with this leg on the orange triangle. And same if I take this bottom one, I need it to match up with this bottom piece. So if we take this pair and do Y over X for one fraction, I can set it equal to the other pair, Y over X here. So that's kind of the method that we're going to be doing today in some problems. So let's get started on a new example. I'm just going to put a new blank piece of paper over this. So that we can, knock my camera over, start from scratch. So if we have triangle like this. We have our right triangle. They've drawn the altitude and they've labeled this part X. We know this piece from here to D is 18, but then from D to B is 10. And they want us to find the length of the altitude X. So we're trying to find this piece right here. So again, we have one big right triangle, but drawing this line down just broke it into two smaller ones. So what I would do is we're going to label and draw each triangle separate. So let's do the smaller one and then the bigger one. So I'm just gonna try and rotate them the same way. Here's our little right angle right here. And then let's draw the bigger half. And I like, again, to have them lined up so they're facing the same direction. If I'm doing this small triangle, the small leg is 10. That's gonna go here on the base. And then the longer leg is X. That's what we're trying to find. But then on the bigger triangle, again, think of taking it and spinning and rotating it. The short part is now right here, that's the X, and the longer leg is coming from this side right here, 18. So we're gonna set up our proportion using both of those, where I take the two pieces that we have and we make a fraction. So I'm gonna do X over 10 and then set it equal to the other one. But again, remember the order matters. Since this leg was on the top in this fraction, the same matching leg needs to be on the top on this fraction. So the 18 is going to go here and the X is going to go on the bottom. So that we have this fraction, X over 10 equals 18 over X. And then just like we've been practicing all unit, we are going to cross multiply. So we get 10 times 18. So that gives us 180. And then we get X times X, which equals X squared. So again, you're just timesing bottom times top. So 10 times 18 is 180, and then set it equal to the other diagonal. So X times X is X squared. And then from here, we're just solving for X. Most of the time we haven't had X squareds though, so hopefully we can remember what to do with those. But we want to get X by itself, so to undo a square, we want to square root. So common mistake I see is people trying to divide by 2. We don't divide by 2, but we square root it. So that square root and that square cancel, so that X is alone. But if I ever do one thing to one side, I have to do it to the other. So we need to take the square root of 180. Well, 180 is not a perfect square. So if you remember when that happens, we have to do our little factor tree. So we want to think, what is a perfect square that goes into 180? And if you can't think of the biggest one, that's okay. It's like on the top of my head, 9, I know goes into it. And I know 9 is a perfect square. So I can say, well, 9 times 20 is going to be 180. Well, I know the square root of 9 is 3, so that comes out. But 20 is not as broken down as it can be. We can break it down a little bit more. So then I want to repeat it. I want to think, well, it's a perfect square that goes into 20. Well, 4 does, and 4 is a perfect square. So we can do 4 times 5. So the square root of 4 is 2. And then now 5 is prime, so we can't break it down anymore, so we're done. So we have these 3 parts that we want to times together. So we would do 3 times 2 is 6. And then we can't do anything with that square root, so we just keep it. So X would equal 6 times the square root of 5. And that would be your answer. So that would be this missing piece on our altitude right here. Would be 6 square roots of 5. And sometimes they might ask you for a decimal. If they do, you can just throw it into a calculator and it'll give you the decimal for that. But okay, so there's one example. And then here's another one. So on this one, they want us to find the unknown. That's this little X right here. Maybe I'll zoom in a little bit. So on this one, we have the altitude as 30. And this short piece going from D to B is 12. And we're trying to find the distance from A to D. So again, if you break the 2 triangles up, here's the small one, and then here's the bigger one, so that we have the right corners lining up together. On the small one, we have these 2 legs that we're using, the 30 and the 12. So the 30 goes to the longer side, the 12 to the shorter. And then if I take this bigger one, again, think of spinning it. So now that the short side is here on the bottom, that lines up with this altitude right here. So the 30 goes to the bottom, and x is what we're trying to find on this long leg. And then we just repeat the process again. So we're going to take this pair and make a fraction. So 30 over 12, and set it equal to the other pair. And again, make sure you're lining up the pieces. If this 30 is on top, the x needs to be on the top as well. Okay, and you'll probably start noticing a pattern here. We do have that diagonal is going to match on these types of problems. So just kind of heads up on that. But we're going to still cross multiply like we have been doing. So I'm going to get 12 times x, which is 12x, and then set that equal to 30 times 30, which is 900. And then from there, we're going to divide by 12, divide by 12, and then x is going to equal, hey, I think my camera might have cut out right there. So I'm just going to double check and record this just in case. So we had 12x equals 900 divided by 12. That cancels and we get x back. And then 900 divided by 12 is 75. So here's our answer on number 2. And then I don't think it recorded the beginning of this one.